Here is an electricity review. It's valid for both courses, for second and third. The difficulty of the problems is different, but you are seeing the same. So if you understand the easiest one, you are going to understand the others. So first of all, we're going to make a resume of series and parallel circuits. Okay, so how is the I, or the current intensity current, is the same in every point in a series one? So I1 is the same as I2, is the same as IN, wherever is then the number, depending the number of resistance. Then V is not going to be the same, so is the addition or the sum of every voltage, every potential difference. And the resistance is R1 plus R2 plus, okay? And then in parallel, okay, we are going to start with the V, with the voltage, potential difference. V is the same in every point. So is V1, V2, is the same as V2, as the same as Vn. So, and then the I, the current intensity, is I1 plus I2 plus IN, okay, wherever is the number, it depending the number of resistors or resistance. And then the resistance, well, both ways. If we have only two resistors, we can do it like this: R1 multiplied R2 divided R1 plus R2. But if we don't have it, if we don't have the only two, we have more than two, is 1 divided T is 1 divided R1 plus 1 divided R2 plus 1N, 1Rn. So this is the resume. And now we are going to make an example of series circuits. We have one circuit like that, like this. V1, V, R1, R2, R1 is 2 ohms, R2 is 1 ohm, and V is 3 volts. Okay? So, and they are asking me for I1, I2, V1, and V2. Okay? Well, first of all, we have to calculate the total resistance. So the easiest way is making here the equivalent circuit. where here is R1, 2. So it's the equivalent of these two resistors. Because we are in a series circuit, this one R1, 2 is the sum of both. So 2 plus 1 is 3 ohms. Okay, now we are going to calculate I with the ohm triangle. We know that I is V divided R. So V is 3, R is 3 also. So we have here 1 ampere. Remember that the units is so important. Okay. Well, we have calculated this. Now I1 and I2. Well, it's the same, because as you remember, and as we see here, in a series one, I is the same as I1 as I2, because it's the same in every point of the circuit. So here is the same as I1, is the same as I2. Okay. So now we are going to calculate V1 and V2. Okay, V1 is I, that is 1. We are going to put here I multiplying R1 and I multiplying R2. Okay, this is I1 multiplying R1 and I2 multiplying R2, but it's the same as I, so I put I. I is 1 multiplying 2, so it's 2 volts, and 1 multiplying 1, so it's 1 volt. So, and to see if we have made it correctly, is 3 volts. That is the same that we have here. Okay? So this is the series one. Now with the parallel. We're going to make one with 3, because with 2 is easiest, and I prefer to do it one that is a little bit difficult. Okay. So R1, R2, R3. Okay. And they are asking me for RT, IT, I1, I2, I3, and B3, for example. Okay, this is so easy, B3, because it's the same as the total one, because we are in parallel and voltage is the same in every point of the circuit, as you remember, or as you have to remember. If you don't remember this, please review. Okay, so RT, we have 3, so is 1 divided RT is 1 divided R1 plus 1 divided R3, R2 plus 1 divided R3. Okay. 1 divided RT is 1 divided, I don't put the values, 2 ohms, 3 ohms, and 6 ohms. Okay, so 1 divided, well, first of all we have to 1 divided 2 plus 1 divided 3 plus 1 divided 6. Okay, 1 divided RT is 1 divided 2. First, we will have to make the minimum common multiple. So is 6, 3 plus 2, 6 divided 3, 2. Okay. 6 divided 6, but we want to make the inverse is the same in this case. So it's 1 ohm. Okay, but you remember in this case we have it so easy because it's the same, the inverse, because it's the same in both cases. But for example, if we have 1 RT is 6 divided 5, we have to change to make the inverse, and will be RT will be 5 divided 6. Okay? Okay. And this I'm going to delete, not create. Okay. So now we have RT, so IT is B divided R. So 9 divided 1 is 9 amperes. Okay? And now I1, I2, and I3. Is V divided R. R1 in this case, R2 in this case, and R3 in this. Okay, so V is 9 in every point of the circuit, divided 2, 1. So V divided R2 is 9 divided 3, and 9 divided 6. One, and this is 3. The sum of these have to be 9 amperes, and is 9 amperes because 4.5 plus 3 is 7.5 plus 1.5 is 9, so 9 amperes. So we have do it, and we have resolved the problem. Also, I can ask you for the power is only to know the formula, and the formula of the power is V multiplying I. So if I ask you for the total power of this one, you only have to multiply 9, multiplying 9 again is 81, and what is the unit? Watt. Okay, so we have here the power. This is for third, not for second. Okay, but also if you know it, better for you. Okay, and if I ask you for the power in each resistor, the only thing you have to do is the same. You have to, P1 for example is V1 multiplying I1. V1 in this case is 9. 9 multiplying 4.5, and I will calculate 40.5 watts. Okay, and with the P2 the same as in P3. In the case of a series one, I is going to be the same in every point, and the one that changes B. Okay, well, I think it's clear, but if it's not clear for you, please ask me in class. Also, as you know, at the breaks, I am solving doubts, and well, please study and don't have doubts. Ask me if you have it. Okay, bye bye.